everybody, go ahead and have a seat. We're gonna get started for today. Okay, so as I mentioned last class, today we're gonna be talking about going from a table graph equation of a quadratic. Okay, we've looked at going from an equation to a table, from a table back to an equation, but now we're gonna add that graphing piece into it. All right, but what's really, really important before we can even start looking at tables and graphs is we have to recall how to factor quadratics. Okay, so I've put up 4 practice problems on the board for us to look at as a way to make sure that we're on the same page of factoring. So I'd like for you guys to do a turn and talk, meaning you're going to be working with the person next to you, okay, not copying their answers, not just letting them do all the work, but we're going to spend a little bit of time collaborating with the person next to you to factor the following 4 quadratics. Let's go about 5 to 7 minutes here factoring quadratics. Okay, I'll be walking around, helping you guys out, making sure we're on the same page. So let's go ahead and start on that. Okay, at this time you guys should have all had a chance to work on factoring these quadratics. Let's go ahead and look at the first one together just as a whole class review to make sure before we start our conversion from table graph equation, we know how to factor. Okay, so Tina, can you please tell me how you started this problem? Good, I want to set up my factorization box. Juan, what goes in my top left-hand corner? Good. And thank you. Okay, if I multiply x squared times 16, Darius, what do I get? 16x squared. And Debbie, what goes down here? Good. Okay, so I'm looking for 2 numbers that multiply to be 16x squared, add to be negative 10x. Okay, Trevor, what do you think? Absolutely. Negative 8x and negative 2x. All right, we can now begin to factor out our box, so we've actually factored our quadratic. Okay, so what times what equals x? Yes, Mackenzie? Good. What times x equals negative 2x? What do you think, Kiana? Good, negative 2. And what times x equals negative 8x? Yep, negative 8. Okay, so we've now factored our quadratic. X minus 2 times x minus 8. What does this equal when we factor? Yes, it has to be set equal to 0. Okay, so Ayana, can you tell us our 2 solutions? X equals positive 2 and positive 8. Okay, thank you. So if x equals positive 2 and positive 8, what does that tell us about our graph? Yes, exactly, Morgan. These are our x-intercepts. Okay, we have the x-intercepts of our graph. Okay, so that's a really good way of beginning to think about our transition from an equation to a graph. Okay, we've looked at our equation. Key characteristics of our equation are that when x equals okay, key characteristics of our graph. Okay, we see this. So what's one way to write this key characteristic of my x-intercept? Yes, 2, 0. X-intercept, when x equals 2, y equals 0, and 8, 0. Just by looking at what we've done so far, do we have any other key characteristic here? Absolutely. Our y-intercept is 0, 16. Jay, can you tell us how we found that? Exactly. When x equals 0, we are left with 16. Our y-intercept is 16. Okay, so we can see some key characteristics of going from an equation to a graph. Awesome. Okay, so let's go ahead and now begin to think, let's actually think now backwards of table to graph. Actually, let's go ahead and take a moment. Now that we've revisited factoring, okay, we've taken a moment as a class to understand that we can factor to go from equation. Okay, we wrote this in factor form. I would like for you guys to do a quick turn and talk with your neighbor. Let's graph this. Let's go from equation to graph. Okay, let's take about 2 minutes here. Go from equation to graph. Okay, you guys have all now had an opportunity to graph this. Okay, let's start with key features. Jen, what do you think? Where should I start? Absolutely, my x-intercepts are +2 and +8. What's another key characteristic I know about my graph from the equation? Say it a little louder, can you? Yes, the y-intercept is -16, or excuse me, +16. You said it correct, I said it wrong. Okay, so our y-intercept is up at +16. What else do we need to know here? Key characteristic. Yes, Ian, the vertex, exactly. Where's the x-coordinate of the vertex? Excuse me, Gracie. How can I find the x-coordinate of the vertex? Yes, it is midway between my two x-intercepts. So my x-coordinate of the vertex is at 5. Okay, 5 what? How would I find the y-coordinate of the vertex? Leslie? Substitute it in. So f of 5. All right, everyone go ahead and take 1 moment if you have not gotten here yet and find the y-ordinate of the vertex. Okay, what's the y-ordinate of my vertex here? Jesse? Exactly, -9. Okay, so we can look from our equation, we had all information necessary to go to our graph. Okay, so we've gone from equation to graph. Do I have any questions on that? Great, let's now go from table to equation. Okay, so I'll put up our table and you're all going to have about 2-3 minutes to see if you can write an equation of the quadratic in any form, factored, vertex, or standard, as in the equation. Okay, we all have an equation on the board. I would like for you to go ahead and write it, or excuse me, have a graph on the board. Let's take like 2 minutes to write an equation and graph it. Okay, so we're going from table to equation and graph. Okay, if you want to do the graph first then the equation, that's fine. Equation then graph, it is your preference. Let's take a few minutes to do that. Work with your table. Okay. All right, Jess, can you tell me how you started this? What key feature did you see in our graph? Absolutely. Our vertex here is at 1, 0. So what form did you choose to write this equation in? In vertex form? Okay. So we have x plus or minus. Which direction we're going? Yes, it's to the right, so -1 squared. The y-ordinate of my vertex is 0. Okay, what is my rate of change? Yes, it is 2. Thank you. How did we know that it was 2? Okay, we went up 1 over 2. So our rate of change there is 2. Okay, so we have the equation. Good job. You guys have gone from table to equation. Let's go ahead and graph it real quick. Stacy, can you tell me how you started the graph? Absolutely. Our vertex is at 1, 0. And then Jay, what do we know? Yes, I'm up 1 over 2 to start. 1 over 2 to start. And I have a quadratic through there. Awesome job, guys. Okay, what I'm going to do in a few moments, now that we've looked at a few class examples, we've gone from equation to graph, equation to graph. We've gone from table to equation, table to graph, graph to equation. Okay, we've looked at 3 different methods here of converting between all these different things that all represent the same quadratic, just in 3 different forms. Okay, I'm going to come around. You guys are already in your groups of 4, which is awesome, and we're going to spend a little bit of time guiding practice here. So you guys all are going to work together on this worksheet that I'm going to give you. Okay, and then do expect next class we're going to take a short assessment, making sure we're all on the same page as far as factoring and graphing goes. Any questions? Awesome. I'm going to come around and pass out this worksheet now.